course, we have to have our starting music for these videos, and Bize it is. Right, so in the third video, and I think we're going to have fall together, we're going to take this event, and then we're going to do it again. So we're going to toss 2 coins, or we're going to toss 1 coin and then another coin. It doesn't matter, they're going to be the same, and let's see why. So let's actually go to a new page. So let's toss a coin. We know what that's going to look like. We're going to have heads, or we're going to have tails. There's the first coin toss. So if we want to, we can kind of think about this part as first toss. We've got heads or tails, and I'm going through this quickly because you saw it in the first video. Half. If you haven't, go back and watch that because each video builds on the previous one. Okay, so heads, tails, there are 2 options. We already looked at some probabilities. Probability of getting a head is a half. Probability of getting a tail, a half. Probability of getting a head or a tail, well, that's 1, because one of these things must happen. So we must have one of those. Now let's look. What happens if we toss the coin again? So we've already had this first toss. And again, kind of, as I put this here, thinking, there's nothing to say this is the golden way of showing how to do this, but it seems to be a useful way of doing it. I've got another way that I've visualized this in terms of areas, which we're not going to go down. As fascinating as it is, let's keep it with one way, which is our tree diagram. So we've tossed the coin, and it comes up heads or tails. Then we want to toss it a second time. So let's play with the different options. If we had tossed a head, we already saw that we're going to go kind of along that path there. We're going to go along and go, we've got a head. Not behind. No, we've got a head. Okay. Now once we've tossed our head, we pick up the coin again, and there are 2 things available to us. Right? When we toss it the second time, having tossed a head the first time, it could become heads or it could be tails. So we represent that by going, we could get heads or we could get tails. Now in the second toss, forgetting about the first toss, what's the probability, just starting here, that we're going to toss a head? Well, each time we toss, we know this is a half, and we've discussed this, so that's why I'm jumping through a half. And it either has to be heads or it must be tails. So that must be a half. So before we carry on with our tree diagram, let's pause and look at a probability and say, what's the probability of getting a head and then getting a second head? So let's look at our diagram. Here we start. First thing we do, on that first coin toss, what must we get? Well, we must go along this path to get us to tossing a head. So it must be a half as our starting point. Then our second bit is, well, our second option is to get a head. So let's go along this path. So we must go along here to get a head. Now, something new that we need to look at is, how do we make sense of this going along a path and then going along another path? And what we do with these probabilities, and we're not investigating why exactly, is to say, well, the probability of going along this path to start with is a half. The probability of going along this path, head, is also a half. So this is a half. So let's see, what do we do with these? Do we add them? Do we subtract them, divide them, multiply them, square them? Well, I'm just telling you at this stage that we multiply them. We've got a half to get to that point, and we multiply by a half to get to that point. So therefore, the probability of tossing a head followed by another head is a quarter. Let's do one more while we're at it. What's the probability of tossing a head and then tossing a tail? Well, we must toss a head to start with. So I'm saying the order does matter. We toss a head and then we toss a tail. So we're going to get a head and then we're going to toss a tail. So it looks as likely. It's a half to get the head, it's a half to get the tail, it's a quarter. So it's as likely that I go head, head as it is that I go heads on the first one and tails on the second one. Okay, let's extend our tree diagram. If on that first toss it was a tail, when we're getting comfortable walking around our tree diagram, we would have gone along this branch of the tree. So let's remove all these other things here and hopefully not get rid of the whole diagram, which is likely. We just need these. So just want to remove these. So there's our diagram. So to start with, walking along our diagram, we're saying what happens if we toss a tail to start with. Okay. Then for our second toss, which is that part of the diagram, then we could have two options. Now the coin's sitting here, and we could get a head or we could get a tail. So these are different to these top ones because it means you've got a tail to start with. So we've got heads and then tails. So heads, then tails. And again, probabilities are a half because each time you toss the coin, it doesn't matter what's happened before. It didn't matter that you got a tail before. It's still a half. Nothing's changed. Okay, so now we can look at it and say, let's look at another probability and say, what's the probability of getting a tail and then a tail? Well, a tail means along here, right? And then another tail means you've gone along there, so it's a half times a half. Everything seems to be a half times a half at the moment. And that's why our next example of doing maths and doing well in the test is going to be a good one, because compound events are a bit nice. Anyway, so a half times a half is a quarter. Just above my head somewhere, I think. So that's how we're working our tree diagram. Now let's add in one more probability that could be a bit more interesting. What's the probability that when I toss this coin twice, toss it, take note of what I got the first time, toss it, take note of what I got the second time. What's the probability of getting one head and one tail? Doesn't matter the order. Doesn't matter, and let me just change the color of this. Doesn't matter the order that we're doing it in. It just means that when we've taken note at the end of our two tosses, I'm going to say, what's the probability that we've got one head and one tail? Okay, so let's think through it. What options do we have? If we got a head on the first throw, so we follow our diagram and got a head, what must have happened in the second throw? Well, if we've got one head, then we've already got our head, so we can't get another head, so we must have got a tail. So in other words, this is the same as we must get a head and then a tail. But there's another option. What happens if we tossed a tail the first time? So remember, this is saying on the first toss, what happened? Well, if we tossed a tail on the first time, what must we toss on the second one? Well, we must have tossed a head, because then we've got one tail and one head. We can't get two tails. And we've seen, as we've built up, well, if we've got these two different options, we need to add them so we can say the probability of getting a tail then a head. Notice these are different. Head then a tail, or a tail then a head. Because on the first toss, heads, and on the second toss, tails. Okay, that's one of the options. Or, starting from the beginning, what could have happened? Tossed tails, and then tossed the second time and got a head, which actually did come up in all of those things. Okay, so Probability of heads, tails. Heads, tails. A half times a half. And yes, we're showing the step each time. Plus probability of tails, heads, a half times a half. So a half times a half. So a half times a half, on it, quarter plus a quarter, which is a half. So many halves, it's getting confusing. And this is the example that we're doing in class to look at, well, what's the probability? And this is what I meant by getting two different things. And I don't think I explained it that well. Hence these videos, and we're keeping on learning all the time. So let's keep at it. Keep asking your questions. Love it. And I really do. I mean that genuinely, sincerely. Let's keep at it. So there's what could happen. The probability of getting one head and one tail is a bit more complicated because we could have got a head and then a tail, or we could have got a tail then a head. Probability of getting two heads, well, that's easy because you just went head, head. That was the only option, half times a half. Probability of getting two tails, tail, tail. Probability of getting a head on the first throw and getting a tail on the second throw. That's what this one meant. We had to get a head and we had to get a tail. And this last one was more complicated. Then we could ask questions like, what's the probability of not getting a... Let's actually do that on this one. I think it'll be worthwhile. So the last one we can look at. Let's see if I can squeeze it in up here. What's the probability? Running out of what's the probability I can find a color? Yellow. What's the probability of not getting a head? Let's rub all this other stuff out and say, and while I'm rubbing it out, think through it. What's the probability that in the two coin tosses there are no heads at all? Okay, in the first throw, can you toss a head? No, because we said no heads at all. So we're not going to go along the head branch. So we must toss a tail to start with. Okay, now that we've tossed a tail with our first throw, can we toss a head? No, it says no heads. So we must go along here. So what's the probability of not tossing any heads? Well, it's the same as probability of tossing a tail, tails in the option. So it's a quarter. What's the probability? Let's really get into it. So let's end this video with a few exciting ones. So let's leave that. What's the probability of tossing at least, so I'm going to do it kind of shorthand and say at least one head. Now we could do this in a very long way and say, let's maybe do that. We could go head, let's look at all of these options. We could go head and then we could toss another head. So two heads, that's at least one head. Or we could toss a head and then do a tail, that's at least one head. So we go half times a half plus a half times a half. Or we could toss a tail, but if we toss a tail, our second one needs to be a head because then we got one head. What's the only thing that we can't toss? A tail and then a tail. Now what's the probability of a tail and then a tail? And this is just taking it to that next level, which is pushing it at this stage, I know. Possibility of doing a tail and then a tail is a quarter. So what's the probability of not doing a tail and then a tail? Doing all the other options. What must all of our options at the end add up to? Should add up to 1. So we can just subtract a quarter, squeeze in, subtract a quarter, let's make that clear, and therefore our probability is 3/4. If you did that the long-winded way, a half times a half plus a half times a half times a half plus a half, you will also get 3/4. Leave it to you to do it the long way. Those are the ideas that you're looking at. That's more than enough for now.